Sometimes integrals that involve substitution are very, very tricky. Consider this one. The integral of x times radical x plus 2 dx. How do we solve it? It turns out that a substitution works, but it's a very tricky method. So watch how I do it here. First of all, normally when you see a radical, it's a composite function, so your instinct might be to substitute for the x plus 2. And that's a good instinct. You want to substitute for the x plus 2. It's not a big substitution. The derivative of that is just, the differential is just going to be dx. That much will replace the x plus 2 with a w, so this will become root w. The dx becomes a dw, but you still have an x here, right? I'll draw that in red just to highlight the fact that I've forgotten this guy. So how do you get rid of this part of the integral? Well, you can use this substitution to solve for x, right? X is going to be w minus 2. And you can replace the x with w minus 2. Now, at first glance, this doesn't look that much simpler. But it is. It's going to be easier to integrate. Take a look at what I have here. I can actually distribute the root w over these two terms and get 2 powers of w. Much easier to integrate than what I started with. W times root w is, remember that root w is like w to the 1/2, so this will be w to the 3/2 minus 2 times root w. Again, root w is w to the 1/2, so this is minus 2w to the 1/2. Now, because these are powers of w, I can use the power rule for antiderivatives, and this becomes w to the, I add 1 to the exponent, so 3/2 plus 1 is 5/2. And I divide by 5/2, which is the same as multiplying by the reciprocal, 2/5. Minus, and I have a 2 here. Antiderivative for w to the 1/2 is going to be w to the 3/2, because I add 1 to the exponent, w to the 3/2. And I divide by 3/2, which is the same as multiplying by 2/3. 2 times 2/3. And so my final answer, I should throw a plus c in here. My answer is going to be 2/5 w to the 5/2 minus 4/3 w to the 3/2 plus c. And I still need to resubstitute for w. W is x plus 2. So my final answer needs to be in terms of x. 2/5 x plus 2 to the 5/2 minus 4/3 x plus 2 to the 3/2 plus c. That's my final answer. Now the key to this problem was substitution, right? A very simple substitution. I substituted w for x plus 2. This little substitution made all the difference because I was able to distribute this root w over the w minus 2 and get everything in terms of powers of w. Substitution is all about taking a complicated integral and writing it in a form that allows you to use your integration formulas. That's all that we did here, was just make it possible to use the power rule for antidifferentiation. So that's it. Try tricks like this, this backward substitution, in order to make a difficult integral simpler.